Good afternoon, everyone. I'm Judy Geller, Director of MetalCon, and I'm here today to welcome you to this edition of MetalCon Live. Today, I am delighted to welcome you to the Art of Metal Wall Panels presented by Tony Sauvé of Peterson Aluminum, and it's brought to you with the courtesy of the Metal Construction Association. Membership to the MCA has many benefits, and now there's one more. Now, new MetalCon exhibitors can enjoy a 50% discount on their first year of membership. For details, contact Janelle. You can see her information on the bottom of the slide. Before Tony takes over, I'd like to remind you to mark your calendar for our next MetalCon Live, which will take place on May 3rd. The topic is on roll forming. And also, registration for MetalCon 2023 is now open, and we are offering a new Super Saver registration option for those who register before April 24th. It's an even better deal than the early bird, so don't delay. Get your registration in today. Finally, if you need any technical help, please reach out to MetalCon support in the chat box. And don't forget to complete the post-webinar survey so you can earn your AIA LUs for today's session. That's it for me. Have a great session. And Tony, over to you.
Okay, thank you very much. Anyways, well, good afternoon, everybody, depending on your time zone. I think we're in Eastern, so it's appropriate to say that. Anyhow, well, I guess we'll get right into it. Anyways, pretty much everything's informal. Anything anybody has any questions, just ask. So, anyway.
Yep. And Tony, go ahead and share your screen. It's going to be that little green button with the arrow at the bottom. You should be good. Perfect.
Engage. Okay, so again, the art of metal wall panels. And getting through all the legal stuff here, copyright, et cetera, et cetera, et cetera. So anyways, this is kind of the do's and don'ts and how to apply them and get the best results that you can from metal wall panels, whether they are composite or exposed fastener, or just a straight 12-inch wide flush panel. So again, it's very informative, and this is a trend that's been taking place in the marketplace for 7, 8, 9, 10 years now, and it's a trend that I see just developing more and more. Oh, anyway, so our learning objectives is basically getting ahead of the problems that's going to happen in construction by working them out in design beforehand. So anyways, and then the other things is problems down the road that may appear like a ticking time bomb 3 to 4 years later. So anyway, so what we'll do is that we'll go over some of the flashing details, basically to allow expansion, contraction. We'll look over how to get water out of the system, et cetera, et cetera. So anyways, again, layouts, where to break panels for expansion, contraction, et cetera. So again, if anybody has any questions, just let me know. So anyway, so design stage. This is very crucial. It's use your manufacturer as a resource as far as how what panels to put where, the condition is going to be by, et cetera, et cetera. Coastal applications, what fasteners to use, what materials, paint, maintenance of it can prevent a lot of things like this happening with rust, et cetera, et cetera. No. So on the coast is that most manufacturers within a 20 to 50 mile perimeter of it and inshore will require some sort of aluminum stainless steel fasteners and everything to make sure everything doesn't rust out like they show here in the picture. Also, other things that may come along is hurricane ratings like Florida building codes, et cetera, et cetera. Pre-planning is crucial again, and your manufacturer should have all the requirements and the codes on their products as tested that they can supply you with to apply anything from any copings, wall panels, standing seam. No. Anyways, so now where do we begin? So we begin at the wall. The most common, the common difficulty that happens in design of the wall is basically how to fasten the panels. Usually it's done with a hat channel or over a solid substrate or a composite material consisting of rigid insulation glued to an OSB, etc. So one thing I can't stress more than enough when I'm on both with architects, designers, and contractors is having the proper substrate underneath there and what you're fastening to. A combination of things like the hat channels that they show here is the placement of it, having them true end to end and plumb up to down is a big concern. Wind loadings play into this as far as spacing. Every manufacturer should have wind loading charts that they can send to you or direct you to on their website to show negative and positive wind pressures. So as you can see in this picture, hat channels are too far apart. My rule of thumb is 30 inches on center. Coastal applications or high wind areas, it may be more, but that is up to a structural engineer. Hat channel is also something, and this will get into P ratings and wind design a little later, is that you can see at this point, the panel clip does not fit the hat channel that the contractor installed. So it's only in there for one screw when the architect may have designed out for a P construction number that would, that's requiring negative load. And you'd see that at this point, you're not getting that because there's only one screw in there. So the other issue with wall panels is oil canning. And oil canning, industry standard, is not a cause for rejection. You can never get rid of oil canning, but you can do stuff to prevent the amount of oil canning and to minimize it. And a lot of this starts in the factory with level tensioning, where you have a coil of metal and it's rolled up, and when you unwind it, it wants to act like a big spring. So it goes through a level tensioner and it x-rays the metal on the master coil, and it stretches it and pushes it. So when it comes out, it doesn't have the memory in, and it goes flat into the machine that's forming the panel. Second thing, if we're talking wall panels here, you're talking about the length of the panel. Since a lot of these wall panels are hidden fastener, hard fastened in with no expansion, their size limitations to how long the panel is. With the panel being is 25 to 26 long maximum, you have to break that panel to allow that panel to expand and contract and not have all that tension in that panel trying to release itself. That's the second way. The third way on this picture is you see that it's a really dark color. So, and dark colors like to absorb light. So another thing is color selection, like a Sierra tan over to the left probably would have been a good idea, et cetera, et cetera. So, and then let's go to that picture's worth 1,000 words onto that. See, is that where the red line, dash line is indicated, if the panel is broken up with a sill flashing and a J, that would reduce the oil canning, just like the shorter ones above and below the window. Sometimes it doesn't like to fit into the design, but these are just ideas to how to control this oil canning. The other way is to increase the gauge, heavier gauge like a heat sink on electronics. It likes to absorb the heat and and not dissipated as much, being a thicker material. 24 gauge is usually the standard in a architectural metal application. If you went to 22 gauge, that would absorb the heat a lot more. It's not going to eliminate all the oil canning, but it'll minimize it down. Another thing is to put in what is called as pencil ribs or line stiffeners or striations, and to break up a 12-inch wide panel. You're breaking it in with 2 pencil ribs. Now you're breaking it into a smaller panel section of 4 or 3 4-inch sections going across and creating stiffening so that oil can cannot spread across the panel. But then again, aesthetics may be at play, it might not be part of your design. So with all the new products coming out and new design ideas, et cetera, there's a lot of different panel applications these days rather than back in the 70s and 80s. Work with your manufacturer. Like this has elbows on it or knuckles, and it looks like a structural panel, and it's going down the side. But what this is conveying here is that you have the long panel and the roof panel in the sun, and a short 2-foot panel break going down. The roof side, the slope side, is going to expand and contract more than the vertical side, and that panel seam will open up and pop off the knuckles. There's other details that could have been done and used here to avoid that and make this a watertight situation that is very low maintenance. Just rely on your panel manufacturer and their reps to guide you through this. Let's say this is a neat picture. A DMV entrance. 2 days in, somebody nails the building. so anyhow, you can't get away from everything. They did everything they could, except they nailed the building there, etc. But you can see where this is kind of a funny picture. But as I can see, the flashing is wrong on the corner flashing. These are things that I pick up onto that. It should have been 2 J's. I don't know if you can see on the sunny side of the corner flashing, there are pop rivets going up and down, meaning they're fastening at that to the panel, that should be a separate piece moving independently of that panel. So. Yeah, so again, oil canning panel lengths is probably the worst thing you can have on your design. And that's what, I can't stress enough that panel length and breaking up that panel will make your job look perfect and better when at the end of the day and the construction phase. But again, rely on your manufacturer or manufacturer's rep to help you in the design. This could solve a lot of problems. Is there any questions so far or anything? I'm going kind of fast.
No questions yet.
Okay, well, we'll continue. Must be doing a good job. So
And as you said that, we had a question come in. So that question is, I have a job coming up using 12-inch flush panels running horizontally. It's a 20-ounce copper, 20-foot runs. Any suggestions for minimizing oil canning? Would pre-punched slotted holes help?
yes, it would. 12-inch wide panel. That's a lot of face that's on there. But yeah, slotted wood would help. Also, the way that I would apply it with the stainless steel screw, and it goes to installer. It goes to installer. I can say integrity is that just like vinyl siding, that they're not they're hanging the flush panel, but they're not screwing it tight to the wall to let it expand and contract. So yeah, So anyway, so the experience of the installer is a real, that worked with copper before would do that. But if you could get a couple of pencil beads, I know it's horizontal, but that would help. But the slotted would help. It's control the oil can. So I hope I understand.
Perfect. Thank you.
So anyway, this considered the performance requirements as such as building height, single skin, composite panels, insulated, aluminum versus steel, etc. Maximum panel length, they all have limitations. It's in bold. It's what I preach is maximum panel length. So anyways, but and trade integration also. I know that it's a rush to get all the trades in there perfectly. It would be nice if all the penetrations were coming through the wall, before your installers got there with the metal cladding. But then again, that's not in a perfect world in the construction industry. So again, where's my building located? And that goes into the first thing, is it along the coast? Along the coast is that a lot of manufacturers for the warranty, as I covered, will require an aluminum substrate, stainless steel screws, and what's also maintenance after to maintenance the panels, as called like a sweetwater wash, basically every year, low pressure wash down with non-salt water, et cetera, just to get the salt dust off of it. What you want to do is check your manufacturer's finish warranty and see if they require that within a certain mileage of a saltwater coast. So corrosive environments, we call it the screws we covered and everything. Also, yeah, any cleats or clips or anything like that should all be stainless steel. So, does the wall assembly on each elevation have suitable framing and substructure for a metal panel attachment? That's the other thing is that if there's a lot of penetrations, you may be weakening that panel, and we'll go over that. There's some examples of how to go about flashing a penetration that's coming through there without making the panel oil can, by just by cutting a simple hole or a penetration in it. Yeah. Oh, another thing is the budget, visibility, and wall area according to the client. This is another thing that saying is rely on your manufacturer, their architectural rep, is that the budget is they can provide you with budget numbers. Talk to them, send them an elevation. They can get you an overall, it's an overall square foot price. It's a lot easier to see if you have some renderings or even the working elevations, and that would be rather than ballpark it, et cetera, and give a couple of different options. Can we go composite? Can we go 22 gauge flush panels? Can we go with a corrugated exterior facet? These are all things that would affect the budget, and it's out there, and nice to get that designed in and factored in before it goes out to bid. Proper framing and attachment, horizontal and vertical, Z channels for insulation, potential panel breaks. Again, as you can see on the right hand side picture, or the finished side, I don't know how it's flip flop to you guys on your screen, but as it's this corrugated hidden fastener panel, as far as they made the panel breaks in there. It's just, yeah, it's controlling the oil canning. It's and becomes a visual aspect of it, along with the skinny vertical windows. Yeah, so.
Hey, Tony, we do have a question that has come through.
Yeah.
And it's, so would you suggest to use SS instead of galvanized for aluminum panels close to shore?
Stainless steel panels that would be great. Costly, but would be great. Yeah, 24 gauge galvanized panel. Even if it's G90 or the AZ50, I would not recommend. Yeah, I would either aluminum or stainless steel. And there's a lot of stainless steel options out there, pricey. You can simulate the stainless steel on the aluminum by going to a metallic color and then getting a 30-year warranty on that. Stainless steel, even though it's a finish, it could change on you or with heat on certain parts of the building or sunlight. It could tarnish, even though stainless steel. But yeah, stainless steel would be great. There's other ways to simulate that at a lower cost and still get you a finish warranty by using aluminum.
Okay, you did have an edit. You said clips, not the panels. So would you recommend stainless steel clips?
Definitely recommend the clips, also stainless steel clips. And then you can, any manufacturer does have ASTM ratings, and Miami-Dade on the ocean and everything should have their UL certified stainless steel clips available for purchase to make that wall assembly.
Perfect. Thank you very much for the answer.
Okay, next slide. Okay, adequate attachment spacing, wind load requirement determined upfront by structural engineer. So this is important also as the spacing. Your manufacturer can provide the positive and negative pressures that are required if you're framing over an open space or a non-open space. And it's a good idea to have that up front with your structural engineer. And what type of Z's or hats behind it. Rule of thumb is 16 gauge or thicker to screw in there so you get the pull out of it. And anyway, but yeah, this is something that could be talked about and conference with your manufacturer, and then to be able to say and avoid that thing. Okay, your Z surface has to be this wide to if you're using a clip, so the clip fits on there, and you're getting the multiple screws in there, and not overhanging the clip. So the same thing, and work in conjunction with insulation or a building framing, I should say, elevation framing system that stands off of it. Those two could be conjoined by your manufacturer, and anyways, and get that designed out right up front. And it may be different as far as along the coastal areas. And if you check on websites and everything, they should have like Miami-Dade or the Florida Building Code, who's available or who has the testing and meets their standards for wall panels, roofing panels, etc. We have splicing details, and this is varies from manufacturer to manufacturer. With a multi-rib panel, depending on the panel, you can lap it like vinyl siding. Otherwise, there's a splice plate behind them, and you would use an 1/8 of an inch gap between the panels. Some of these multi-ribs, if you don't like the vertical aspect, you can use a multi-rib and lap it with the panel lap ends not showing like towards a parking lot or a sidewalk, just kind of like on your house and everything. But again, I know I keep saying this, but refer to your manufacturers on which ones can lap decently and which ones would need a splice plate. So, and then mixing it up. So here we're, you could take the metal, and it's getting into the aesthetics part of it, and having 3 different types of metal on the building, just in metal profiles between the standing seam, dormers, walls, accent walls, etc., etc. But that's there's so many different profiles per manufacturer nowadays that you can probably get the look that you want, compared to back in 2005, 2006, when you're only looking for metal panels. If it wasn't a pre-engineered building, it was just an architectural panel, you're only looking at, 3 different styles, 4 different styles of siding. So yeah, it's now there's just dozens out there that you can use. So structural engineering of record must be brought into the equation much earlier than the past. And we covered this a little bit ago, and correct loads by zones. And this has a lot to do with taller buildings and where it's located. If it's located in the downtown urban area or city, or in the plains and the wind ratings below it, then this is all that the structural engineer would take into consideration when working with the fastening rates and where those how far the supports are put apart, etc. So it's best to get that on board before, sooner than later. So anyways, and this is examples of a metal roof example of fastening in wind zones on the corner. So this would apply to a building also. The structural engineer, wind loading, if you will have tighter fastening rates at the corners, and maybe out, depending on where an inside corner is, if there's a vacuum there, et cetera, for your positive and negative pressures. And that is making sure that everything stays on the building like it should. So with the wind loading and everything, and then a lot of engineered building component people will have an engineer on staff that would actually do this, run through the program and certify it before they're buying your girt system for fastening panels too. And another report and zone. So yeah, this is what I talked about. We can have it with a corner or somewhere where wind would catch, or having negative pressures under that. So you see that on the soffit framing there, instead of 2 foot on center, they're putting the framing a little closer so that soffit won't pump up and down and create noise and eventually disengage and suck out if there was only a center span to hook onto, or just at the ends. Behind that also is that the flush panels are going up at that pressure point with the Z-girts much closer. So so if you look at that, if these flush panels were only placed with girts that were 30 inches on center, you can see at this point with the doorway underneath there and the wind coming up underneath that soffit and curling around, it's going to want to suck those panels out and disengage those panels. I've came across this in my career a lot in farm country, where they have schools and soffits and wall panels and everything, where the panels would actually disengage, not from being pushed in, but from being pulled out from negative pressure. So again, there's another picture of exceeding maximum panel length and having the wall go in and out because of expansion and contraction. So if you're looking at it again, having the panel overlap, some external panels will not do that, some will. Refer to your manufacturer. But again, it's good to have some panel breaks somewhere, so you're not getting that oil can. So proper organization of the Z channels for horizontal wall installation. Okay, so this is where I'm going to break into field experience here. The key thing to having a nice wall, whether it be multi-rib or a flush panel, is having the surface perfectly flat. I know no construction sites are perfect as far as wall framing. 1/16 of an inch or more, they're going to wave in and out. This goes from contractor experience, and when they're putting up their Z's, if they're and then putting their panels across it, they should be shimming the panels in or out before they fasten it at that Z, so the panels won't follow the contour of the wall. If it does, you're going to see the panel want to gap and disengage. So those panels are pretty stiff at the joints and then at the lap itself. So it's Vol being plumb and true is very important. So again, this is a lap, and you can see where they have it. Staggering the splice, just like vinyl siding, will help hide those laps if you're overlapping them. Oh, and I noticed that in this picture also, it looks like the framing is at 16 inches on center with the hat channels going up. So this tells me that it's in a zone that may have a lot of wind or some very constricted building codes. Well, anyways, okay, so if something doesn't look right, it probably isn't. Yeah, examine basic framing issues. It all starts from out. So if you have a wall that's crooked, adding on Z's or hat channels, and that's gonna basically amplify the issue of it not being true, because you're compounding that error all the way out. So this is something that an experienced contractor that we want to do a good job of basically check everything and how true his framing is. So just like this is a good example, as you see, as far as the roof cladding and will reflect the deck. If you look at the picture with the straight edge going in front, the darker one or whatever, screwing those panels down just like on a wall, it's going to follow that contour. Same thing again, making sure that your substrate or hat channels or your framing system is very, very level. Actually, this is one of my favorite pictures. I actually took this picture. This is where I grew up in West Branch, Michigan. I was coming around the corner of this contractor that had a roll former and saw this and said, "Oh boy, I wonder if he's going to get any work." A small town population, graduating class of 300. So, anyways, but if you notice that, it's just that this was actually amplified by he put this roof over asphalt shingles. So this is why this is going this way. Improper flashing details. It's just So this is a really good picture. I think this picture it's used all over the place now. So, any questions so far? Okay, so and if you look to the right of the smaller dormer over the porch, as you see a line going through there, 2 feet down from the ridge, showing that there was a surface condition underneath there of the deck. Below the shingles that's now appearing through the metal roof itself. Now, okay, dissimilar metals. So anyway, so this is something. It's the race to get the panels on and get there before getting there before the HVAC guys or any penetrations are coming through. So this is an improper way to do it. These panels will rust out with the copper there, or even if it was any black pipe or something coming through, it's not the proper way to do it. Same thing with this one. It says it's collaborating, but I would never allow that type of penetration in my metal siding with caulk around it. We'll get into the good stuff here. Yes. Again, this is coordination that needs to be done or specified on elevations. Okay, where this stuff comes through, here's your bank, and you need to do this and coordinate with the HVAC and provide the proper flashing or area for their penetrations to come through. It's hard to do, but let's see here. This is what it should look like. Is that piece of metal caulk J-channeled around, the flashing drains either side, The metal around the hot pipes or cold pipes or whatever can expand and contract really well. And then the sealant can do that also without ruining the integrity of the seal itself. So your J channel going around and giving a channel for the water to go out and around rather than even to drain down or chance to go on the pipe or the penetration. So the box down that's showing the going around the heat ducts there, that's another good way to do it, depending on the aesthetics. But of course, you want to hide all your HVAC somewhere on the building. Any other questions so far? Moving fast. Okay. So this is a really good picture also. Again, penetration coming through square. It's J-channeled around. The panels are broken up with a vertical J-channel, and then you can make a cover to go over that to make a monolithic up and down onto that. So yeah, this is a really good example of the way things should be. So, and then with this picture here under that, showing again the different types of metal wall that you can put on just to take an old building and modernize it with that. So we have composite panels by the glass entryway combined with horizontal metal wall panels and existing steel building in the back. So, yeah, 032 aluminum, scratch paint, and like that. It's another thing is that taking away being close to a coast of the ocean of what material you're speccing out for durability. Schools, community centers, along sidewalks, etc. I would prefer or recommend going with the steel material, less it could take a dent, a shovel hit a lot better than aluminum that will rip open, etc., etc. Here, so anyway, that's another thing is choosing the right material. Further up, where you're not going to take a hit by a dodgeball playground, use aluminum if you need to. So, anyways, another good example of breaking up the panel and getting a vertical joint up there can control oil canning. And they hit it behind the downspouts. I've seen a lot of people, designers, is to continue the line up from the window mullions and break them up there. So it can be possibly put into your design as where how to break these panels up. So again, sometimes no flashing brakes is the way to go. It's animal shelter, etc., etc. Just use your panel manufacturer architectural rep to figure out which one should go up there. That you can either do a lap or a longer panel length, so you will not get the oil canning. Just like. And then as far as bringing into the interior, then you see they can start hiding panel breaks above that wall opening, going vertical with the J channel. Looks like they used my trick with the cover on it. So, okay, so all silver mica finish. This is another thing that you can do. It's on a mica finish. It's also metallic that is a directional finish. And this is important that all the panels need to be installed the same way. The manufacturer should have an arrow in the back of the panel. So when they're installing the panels, that the contractor knows that it goes this way, because when the panel is sprayed with the paint, it's sprayed at an angle. So if you look at it at one angle, it's going to be a different tone or shade than you look at it from a different side. So if you're reversing the panels back and forth, you get basically you're getting different colored panels with on the same batch of paint. So that's showing that on the horizontal to the vertical, it's the same finish, the same paint finish, but you can see the different shape. But taking that that complication and incorporating into their design is another thing that you can do, is to just to shade off, basically to exemplify the vertical and the gable. Again, the panel lengths are broken up by continuing the size of the window up with 2 J channels in that cover piece. Any questions? Okay. So
Nope, you're good to go.
okay. So yeah, key basic details and the layout of these steel flashing details to provide. Yeah. So the other thing, okay, to in your design, we're going to back up one here. Well, we're going to go forward. Okay. So on these flashings, is that all these flashings are customizable. If you notice the corner flashing compared to the panel break above the window, is a little bigger than the other. You can specify that you need that out instead of the 4 inches to a 6 inches if you want to exemplify that corner. All flashings are customizable. Just work with your manufacturer. And yeah, it's just nowadays it's just putting it into the computer and having it pump out that piece of flashing and the desired width. So that's okay. So okay. Again, a race to the finish and everything. This is like a roof penetration going through here, and it looks like the ocean basically. The Joe's Crab Shack here. So they're penetrating the panel. If this was 24 gauge, you would have a real problem. 032, it's not going to rust. You can add the stuff later on, just caulk it real well, etc. Another thing to have, if you're going to have additions or anything going on, 032 might be the better choice. But then again, it's basically your design elements that you want to do under that. So through wall panels relies on caulk for water tightness, copper or ground or other wire touching the aluminum panel. Again, that is dissimilar metals. And this is probably an afterthought, but yeah, it's something that probably going to cause them a lot of heartache just from that one copper wire going through there. The McDonald's. Yeah. So showing that signage does not have to be a worry point, as McDonald's putting everything on top and not passing through the panels. Those look like they are corrugated panels up there. And I could just see over the drive-through where the welcome sign is where the panel break is. And they did it. They went from, they applied going from the right. So the joint is pretty well hidden. If that was applied the other way, we would see a definite line going through there, even with the great picture. So, yeah, so the structural wall supports and exposed fastener panels, enclosed stone walls, et cetera, and rather than do a whole retrofit and tearing them down, et cetera. Just clad everything up, and again, it's if you look at the flashing detail, is that it's pretty good, and after that, it's not a visual thing. I would have went with the box and the J channels, but I guess that, there's a budget also, I guess, and it's hidden beauty. So metal canopies provide shade while trying into the accenting metal wall panels under that. So again, it's a way of accent, tying it all in. Again, on the canopies is structural engineer. A lot of wind load, might have to go to hurricane standards, et cetera. I've seen palm trees, so I'm thinking ocean. Any questions? No? Okay. Do that. Okay. same panel profile, same panel installation, one reverse run as far as that. So what they're doing is that they're actually reverse running the panel to get two different styles out of the same panel run. It's just basically flipping the the coil over the machine and getting that on the outside for its exposed fastener. So you can see the panels are overlapped on this one. So we're looking at this one. Another neat thing is all metal, et cetera, et cetera. Again, this screams out that it's in a flood zone, hurricane next to an ocean. As far as the pillars and yeah. And then the other going back as far as from the right hand side of the picture, you see the panel line and the joints going up and down. They could have staggered them, but in this case, it looks, it's probably better aesthetics to have the panel joint line up. So end laps, and this is somewhere where it's unlapped and it's on this corrugated panel that's perforated. So I would have done it with a J channel. That way it would have broke it up, but basically you're plugging up all the holes. So at this point it goes to whatever you feel aesthetically comfortable with. So anyways, preparation project onto that. Instead of perforating the panel, just some ideas. This is 040 perforated panel. There are different perforated panels for ventilation. There are about 7 different options to perforate a panel. Conditions that should be 040 to 050, depending on your perforation size. Bigger perforation will make the panel weak, and then we're getting into more fasteners, et cetera, and so things to consider. Also, it's the ventilation out of that. These work great for parking garages, et cetera, as far as perforated panels and bringing light and air through while concealing. And these ones I looked at like these are really perforated. Just to modernize and hold no value except to make the thing look good. So on this old wall. Again, shading 7.2 panel perforated under that. And I don't know if they were stating that the roof is not walkable. So the more perforation you get, the weaker the panel gets as far as that. So perforated M36 panel, which is exposed fastener. This is from the back side of a screen wall up there. As you can see, it gives a ghostly visual effect. And typically you're looking at a rule of thumb, 30 inches on center for the Z's and the hats, but they have probably just calculations on this as being up 4 to 5 stories where it's exposed from the back, and for pressure and wind that they had to move those dirts and be closer in between to get their massing to be calculated. Perforated wall screen again, and we see a lot of this. This one's 51% airspace, so very weak panels, et cetera, more accent than anything, but it gives a really neat effect. One final point. Okay, material is 100% recyclable. So anyway, so it's aluminum and this and that, so it's good for the environment. Everything from steel, aluminum, et cetera. And everything. So that is my presentation. I am open to questions. I know I kind of moved through it very fast. I'm more of a specific question kind of guy.
That is perfectly fine. I don't have any current questions that have come through in the past little while. You've answered all of them so far. So I'm gonna start doing your outro, and if any questions come through, I'll stop and speak right up. So first of all, a huge thank you to Tony for doing this presentation for us. A big thank you to the MCA again for sponsoring this presentation. I also want to thank all of you that are listening live today, taking the time out of your incredibly busy days to join us. If you do need your credits or a certificate of attendance, all you need to do is fill out a few questions, just essentially your name, and if you are an AIA member, your AIA number, and you'll be able to receive that certificate immediately following this session. If you have any further questions about this topic, you're more than welcome to reach out to MetalCon or the MCA, and we are happy to get you in touch with whoever may be best suited to answer that question. Again, thank you all so much for joining. If you're watching in the future, thanks for joining us in the future, mind you. And Tony, again, thank you so much for joining us. We appreciate it. Hopefully we'll see you again for a future MetalCon Live. No questions have come through since I've been doing this outro. So with that all being said and done, I'll let you all go for the day. Thanks for joining us, everybody. Have a great one. We'll see you on May 3rd. Bye.